Hello, my name is Tusharan Mohan, ID 19547, petroleum engineer, third year first. So today I'm going to explain about the introduction. So first, drill stem test or DST. It is actually a temporary completion which enables formation evaluation and records the natural characteristics from a reservoir or zone of interest in either open or cased hole applications. Drill stem testing also is a procedure to determine the productivity, capacity, pressure, permeability, and extent of an oil or gas reservoir. Next, I'm going to explain about wireline formation test. The wireline formation pressure measurement is acquired by inserting a probe into a borehole wall and performing a mini drawdown and build up by withdrawing a small amount of formation fluid and then waiting for the pressure to build up to the formation pore pressure. This measurement can provide formation pressures along the borehole. Okay, next for the drill stem test part, I'm going to let my colleague Vishnu to present about the drill stem test. Thank you.
Hi, my name is Vishnu, and today I'm going to talk about drill stem test. What is drill stem test? Drill stem test is a procedure for isolating and testing pressure, permeability, productive capacity of geological formation during the drilling of a well. It is also an important measurement of pressure behavior which we use to estimate the reservoir pressure at the drill stem. It is also a valuable way to obtain information on formation fluid and establishing whether a well has found a commercial hydrocarbon reservoir. In this case, we use this information to estimate the well potential. Besides, DST can also be run in both open hole and cased hole with a single or dual packer, which will be further discussed later. Next, I'm going to talk about the objective of performing DST. The objectives of performing DST or drill stem tests is to identify reservoir fluid, to indicate well productivity, to estimate pressure transient data for permeability, skin factor, and static reservoir pressure. So we can estimate all these data and analyze them using semi-log plot, pressure, and derivative type curves, just like any other transient test. Now let's move on to the procedure on how to perform drill stem tests. Is the preparation. The electronic pressure gauges are programmed for the required data intervals and they are placed into the pressure recorder chambers. Going in the hole. DST assembly and the drill pipe or the drill stem are lowered into the hole. The displaced mud from the wellbore flows out to the mud tank. The tester valve is closed and the shut-in valve is open during running in hole. This allows the drilling mud to go into the perforated anchor and out from the bypass ports without entering the drill string. The pressure recorders show the pressure due to the mud column height when we are reaching the bottom and setting the packer. After the pipe reaches the bottom, the packer is set. It is compressed and expanded by supplying the weight of the drill string on the packer. These packers isolates the lower zone from the rest of the wellbore and it isolates the region of interest when we are conducting the test. The tester valve is open automatically a few minutes after the packer is set and the formation fluids enter the pipe. The tester valve stays open until the test is completed and the packer is unset. The shut-in and the flow periods are controlled by the shut-in valve. Shut-in valve is closed for shut-in periods and open for flow periods by rotating the drill string from the surface. Two flow and two shut-in periods are performed. At the end of the test, the shut-in valve is closed. It traps any formation fluid above it. Now move on to the equalizing part of the procedure. The weight is taken off the string and the tester valve is closed. This opens the bypass valve and therefore pressure is equalized across the packer. Next, removing the packer and pulling out the hole. The weight is taken off the packer by pulling the string. The packer contracts and the drill pipes are pulled out from the hole. Reservoir fluid samples are collected as the fluid filled pipe comes to the surface. If it is not desired to have reservoir fluid when pulling out of hole, drilling mud is pumped through the reverse circulation valve, place the reservoir fluid in the drill string before beginning to pull out of hole. Now let's move on to the pressure recovery chart during the DST process. At the beginning of the chart, it shows that it is the start of running in hole for the DST tools and the drill pipes. The pressure recorder shows increasing pressure. This is due to the increasing mud column height or hydrostatic head as the recorders move down together with the test string. Now the tool is at the bottom. The packer is not set yet. The pressure is due to the height of the total mud column. When the packer is set, the mud is compressed and the pressure increases slightly. This shows the sudden increase in the pressure in the graph. The tester valve is open for the initial flow period. Therefore, the pressure drops to the cushion column height. If the cushion is not used, which means the DSC string is empty, the pressure is close or is almost equals to the atmospheric pressure. The first flow period, which is also known as pre-flow. The reservoir fluid enters the test string. As the height of the column above the pressure recorder rises, it shows higher pressure. The end of flow period. The shut-in valve is closed. The first build-up period is started. The first shut-in period. The pressure increases as the fluid below the shut-in valve is compressed due to the pressure build-up. This can be seen in the graph as increasing. Now moving on to the end of the first shut-in period. At this point, the shut-in valve is closed, and you can see that it is clearly written in the pressure recovery chart as the initial shut-in pressure. The beginning of second flow period. Because of the flow period, the pressure drops down to the level of point, also known as initial flow. This point is shown in the graph as the initial flow. Thus, the pressure recorder shows the pressure due to the column height above the recorder. Now, the second flow period, or also known as final flow. Similar to the first flow period, the reservoir fluid enters the test string. As the height of the column above the pressure recorder rises, the recorder shows higher pressure. Now, the end of second flow period. The shut-in valve is closed. The second build-up period is started. The second shut-in period. The pressure increases as the fluid below the shut-in valve is compressed due to the pressure build-up. The end of the second shut-in period and end of test. The operation of pulling the DST string out of hole is started. The tester valve is shut in. The packer is released. The recorder reads the mud pressure due to the total mud column height. So the pressure is shown in the graph as the final hydrostatic pressure, which is equal to the initial hydrostatic pressure. So there is no mud loss above the packer during the test. So pulling out of hole continues until all the strings are pulled out of hole. The recorder shows the decreasing pressure. This is due to the decreasing mud column height or hydrostatic head as the recorder moves up together with the DST string.
Hello, I'm Nashri 18938. I will explain about wireline formation test. Formation testers are a class of wireline tools used to measure the downhole pressure of formations. Stationary measurements of formation pressure in an open hole are made at any number of depths during a single trip into the hole. These pressure measurements are useful to determine variation in pressure among various formations, gradients of fluid pressure within a formation that can indicate fluid content, gas oil or water oil contents, and local permeability. Comparison with initial reservoir pressures in development wells may indicate zonal pressure depletion. Formation testers are also used to retrieve samples containing fluids. When the tool is being moved downhole, the formation tester is in retracted configuration. When a depth is selected for a pressure measurement, the formation tester is activated and hydraulically set or pressed against the formation. These conditions are shown schematically in Figure 1. Two modes of measurement exist. First, a pre-test measurement in which formation pressures are examined, and second, a fluid sample measurement in which formation fluids are physically withdrawn and retrieved to the surface for examination. The sequence of a tool movement required to measure formation pressure begins when the formation tester is activated at a selected depth. The sampling system shown in Figure 2 illustrates how this measurement is made. Prior to activating the tool, the pressure gauge measures hydrostatic mud column pressure. Upon activation, the equalizing valve is shut, the packet and the probe are pushed against the formation. The tool is now set. Within a few seconds, the pistons of the pretest chambers begin to withdraw, causing fluid from the formation to flow into the tool through the packet and the probe assembly. The pretests are done sequentially with a small volume of fluid drawn into chamber 1 over about 15 seconds, followed by a similar volume flowing into chamber 2 at higher flow rates. Upon completion of pretest, a sample can be taken or the tool can be retracted. During retraction, the equalizing valve is opened and the pretest piston expels the fluid taken in. The tool is now ready for the next test step.
My name is Shiva Selvin Serwe, son of Munyandi, ID 18948, Bachelor of Engineering, third year first semester, and today I'll be explaining about pressure measurement, result from wireline formation test, as well as comparison between DST and wireline formation test. Firstly, pressure measurement. Pressure measurement is a process of evaluation. The pressure is monitored in two sampling systems. As you can see the diagram, it shows the typical pressure recorded in a reservoir. In this record, the time increases as it moves to the right, and also the pressure and flow rate increases as it moves upwards. Initially, the equalizing valve is open and the recorded pressure is the hydrostatic mud column pressure. During the drawdown, the pressure drops, stabilizes, and declines at the second pretest. After second pretest, the flow stops and the pressure builds up. Actual formation pressure can be taken from when the pressure becomes stable or estimated from character of build-up if it's not stable. Moving on to result from wireline formation test. Wireline formation test will allow you to obtain four results. Firstly, the pressure variation from various formations. Secondly, fluid pressure gradient. Thirdly, gas oil or water oil contact. And fourthly, permeability of a reservoir. Lastly, the comparison between DST and wireline formation test. DST, which stands for drill stem test, it can be performed in both open and cased hole environment with a single or dual packer. It provides exploration teams with valuable information about the nature of the reservoir, as well as to determine the fluids present and the rate which they can be produced. Lastly, which is the wireline formation test. It's widely used in the exploration, appraisal, and reservoir development projects. In some areas, host conditions prohibit the use of DST as temporary wellbore completion, and in others, where the cost of the required number of DST are prohibited. WFT, which stands for Wireline Formation Test, is frequently used in information evaluation work. It determines the permeability, barriers, and highly permeability streak along the wellbore, and also horizontal and vertical permeability, and also their distribution along the wellbore. With that, I hope my explanation will give you a brief idea about pressure measurement, wireline formation test, and also the comparison between DST and wireline formation test. With that, thanks a lot.
Assalamualaikum. My name is Tuan Muhammad Irfan, ID 19178. Okay, types of wireline formation tester. There are two types of wireline formation tester. The first one is the repeat formation tester. A repeat formation tester, or RFT, measures pressure at specific points in the borehole. A tool is run down into the hole to get a continuous digital readout of the hydrostatic pressure. At any point, a rubber pad is hydraulically forced into the wall of the hole. A tube is then centered of the pad is forced against the formation. This will create a low pressure area and force the fluid into the chambers. The formation pressure is measured by the formation sampler when it is extended from the tool to contact the formation. The fluid samples from the formation can also be taken with the tool. A repeat formation tester is usually used in open hole. The next one is a formation interval tester. A formation interval tester, or FIT, uses only a single chamber compared to multiple chamber in repeat formation tests. The, the process of formation interval tester is similar to the repeat formation tester, except that it only uses a single chamber. A shape charge is fired into the formation to open a passageway into the chamber. Measure sampling, sharp in, and hydrostatic pressure. Formation interval tester can only perform one test per trip and usually can be used in case or open hole. The advantages and disadvantages of wireline formation tester. The advantages are it is accurate and quick, can run many samples per test, low cost per test, it can measure fluid samples and can also determine horizontal and vertical permeability. While the disadvantages are it may be unreliable for fractured reservoir. The skin damage occurs in the borehole can cause major error. The wireline formation test may also stick into the borehole and it can only be used in small area of investigation. So that is it for my part. Thank you.
So, for the conclusion, there are four conclusions, which is first, wireline tool is a tool to measure the downhole pressure of formations. The second one, it can be determined variation in pressure among various formation, gradients of fluid pressure within a formation that can indicate fluid content, gas, oil or water, oil contacts, and local permeability. And the third one is there are two types of wireline formation testers that were discussed by my friends. The first one is RFT, which is repeated formation tester, and formation interval tester. Last one is it is quick. The method of this test is quick, inexpensive, and thus it may reduce the safety and environmental risk. Thank you. That's all from me.